Okay, we're here with John Burkhardt with the Norwegian Institute of Air Research, and millions of objects around the world is his topic. Let's hear what this is about.
Thank you. This is a high-level overview presentation of our atmospheric modeling system that we've developed at the Norwegian Institute for Air Research. I started working with Python to replace my MATLAB toolchain in data analysis, and there was a lot of bleed over into everything else that I was doing, and after several years I ended up with what I call a cradle-to-grave full life cycle of the atmospheric modeling process. And so essentially we've replaced some standard steps of user-generated input data. They can do that now through the web, or we have files, Python scripts that will automatically replace text-based input files, but we can also automate that with satellite information and other data. The model is now run with process control through Python, and the output data can then be post-processed and put onto our servers where it's batch processed. And then we've recently started using Django to provide visualizations for all the data. So having something like this in place and ready to run has enabled us to do some interesting things. We were able to react quite rapidly in response to the Eyjafjallajökull volcanic eruptions, and more recently for the emergency response and analysis of the Fukushima Daiichi nuclear power plant. So on the poster, I present some information on that scenario and what happened, and the fact that we had our server up and running, and there's some statistics that I show here that you have to zoom in quite close to look at, but we go from roughly 10 to 100 hits per hour, and then after we released these products onto the web, we were seeing 10,000 or more hits per hour coming from Japan, and you can see the diurnal cycling in the data.
So are you gathering data from sensors? What is it exactly that you're detecting and saving? And you have a timeline over time. Can we dial back and look at the atmosphere a year ago? Is that kind of thing you're doing?
Yeah, so the models run with offline meteorological forecasting model from either ECMWF or the GFS systems at NCAR here or NOAA. We can run it in a forward mode or a backwards mode. In this for Fukushima, what we did was we ran it forward, making some gross assumptions about the releases, and that just gives you a general overview of where the air mass may be going. Following the incident, we did a full analysis where we ran the mode forward in time, having much more accuracy, and now data collected globally, and we were able to do an inverse analysis to refine the emissions estimates.
What kind of database software do you have in the back end here, do you think?
It's a good question you ask, because that's hidden behind this script.
Not supposed to know. All right.
It's the next step is to integrate this into a database, because if you can believe it, we're all doing this based off of file system read writes, and text files. So that's the next.
What we call that's what we call NoSQL, and that's certainly a viable way to go these days. Thank you, sir. Appreciate your time.